you touch and then you feel that is also an observation. And then, of course, whatever instruments that we put into the weather observing system, that they play a very important role. Somewhere around 1630, 35, when the first, the temperature thermometer, like mercury thermometer and barometer, meant for pressure, they were invented at that time, and from there onwards, we can say that the entire weather fraternity or entire science fraternity or worldwide, we started taking the weather observation using the instrument. So, of course, it went from analog to digital, and now so many other things are also coming up. I just want to show you one contrast picture here. So when we talk about the weather observation, so yeah, we need equipment, we need instrument, and we need to function them all the time. But suppose if we ignore, once you install the equipment, install the instrument, and then we don't go to see that whether it is okay or not, then probably what you see on the left hand side, that is what can happen to that instrument and its surrounding, and then it will result into the wrong readings also. This is an automatic weather station. I'm not mentioning which is that place, but ideally, how an automatic weather station or instrument setup could be, that I've tried to show it on the right hand side, where you have a very nice, compound, and the mast of 10 meters is standing with the guy ropes, and then you have solar panel, and then it's an automatic weather station which will measure, all the weather parameters every 15 minutes, and sometimes if required, I can change that from 15 minutes to 5 minutes or 2 minutes also, sitting in my control room. These are the technology which I'm sure many of you may be knowing also, that this time interval can be changed also, especially during the severe weather. So this was about the digital. What about the analog equipment? Analog equipment, the right hand side, the left hand side, what you see, a broken jar. It is nothing but it's a rain gauge. Okay, it's a rain gauge, and it's a SRRG. I mean, there is a chart in that in which the rain is plotted. So the rain is expected to come from the top, but if you see the jar, it is broken. The exposure condition of the equipment which is kept there is not ideal, and in that case, it could result in a wrong reading, or it could result in no reading also. How it could be, the another right hand side, if you see, then I see one mast with a solar panel and then one steel container here. If you see here, then this is nothing but it is an automatic rain gauge. But this looks good. This looks good. It is not as bad as that. But then there is one problem. What is the problem? You see, it is completely covered with shadow. Shadow means what? The trees are growing over it. So whenever the rain will fall, the rain will be obstructed by the trees, and then you will not get the exact rain. Then you may say that yes, it rained in our district so heavy, but the rain reported is so less. So this could be one issue, that yes, instrument is working okay, but it is covered with some bushes and something like that on the top, and the exposure condition is not very good or very ideal. So, we need to take care of the instrument, especially when it comes to any measurement. Let it be any field. Let it be a field of, say, for example, let it be a field of health. In the hospital, suppose if somebody is using the wrong thermometer or wrong stethoscope, what it will lead to something disaster. Similarly, the weather, whatever equipment we are using, we need to take care of them regularly. That was in SOP, the standard operating procedure, that every 3 months we need to go and check whether the equipment is okay or not, if it is unattended. If it is in the observatory compound, then every day people will see that. So this is what I just wanted to bring it to all of you. Yeah. Since this topic is going to talk about, the severe weather, and we all know now that, the root cause of the severe weather is the climate change. Now, suppose if somebody is asking you, what is the current rate of climate change? So, for example, you are driving a vehicle and if somebody is asking you, what is the speed at which you are driving? Where you will see, whether you will see outside or whether you will see your speedometer. I think you will see your speedometer. Similarly, when I want to know what is the rate of the climate change, it is obvious that the answer to this question depends upon the accurate observation, and our ability to detect the small trends rest on the high quality measurements. So, accurate observations are the foundation of the studies toward the climate change. So, what we need, the earlier two slides, why I showed you, because we need observations. We need observation, but not just observation, we need also the accurate observation. And if we read accurate observation, probably, many of the things, we will understand the trend, whether it is happening, decreasing, or it is same, something like that. And then it is not just one observation. We need observation on a very long bandwidth. 5 year? No. 10 year? No. Maybe we require for 30 years, or maybe we require for 100 years, or maybe more than that. And I'm telling you that India Meteorological Department there are some observatories, especially in South also, that there are observatories which are more than 100 years old. Trivandrum is one of them. Chennai is more than 200, that earlier it was called as Madras. So that is also more than 200 years old. Calcutta, maybe 250, 300 years old. Bombay, that is Mumbai, again it is somewhere around 150, 200 years old. So there are many observatories who are centennial observatories, like they have the data for last 100 years. I said that the data is very important. The weather observations are very important. This is what, I've taken a slide from, the WMO site. It indicates that, that we have the elements on the left-hand side. What are the elements? Elements are like, the weather, climate, and water. Of course, there could be many other also. And all these elements, we are taking the observations. That observation, it goes vertically and downward in two components. One is processing and data management, and downward it is going into the R&D, that is research and development. So from the observation, whatever data we get, it is processed. It is processed for what? It is processed for consistency, quality checks, whether the data is good, whether it has come timely, or whether it is old data which is coming. All those sort of things. Hello? Hello? Will I continue? Yeah, thank you. So all this data which is scrutinized and in the real time it is quality checked, it goes into the modeling. Modeling means the numerical weather forecasting. That is the latest technique by which I can give the forecast for next 3 days, 5 days, 15 days, 1 month, or season, like a monsoon season or a northeast monsoon season. I can tell how it could be, how it will be, depending upon the models which I am using. I can tell, I can use the model even to tell what is going to happen for next half an hour or 3 hours also. So models are there. And then based on the modeling, the forecast is generated. Model gives guidance. There is some confusion, among many of the weather enthusiasts and many other people. Whatever they see in the model output, is it a forecast? I think I should use a correct word, that it's not a forecast, but it's a guidance to give the forecast. There comes, the meteorologist in the picture. The meteorologist sees, the model output, and based on the model output, he generates the forecast, and then he gives to the various stakeholders, various service delivery. And the service delivery also has a big challenge. That also I will talk, that it has to go in real time. What forecast I'm generating now, right now, it should go immediately to all the stakeholders, all the users in the state government, central government, private sector, general public, farmers, agriculture, disaster management, and so on and so forth. Everyone should get it. While all this is happening, the R&D is also happening. R&D is happening in what? R&D is happening in observation. R&D is happening in modeling. R&D is happening in forecasting. And R&D is also happening in the service delivery also. So the dissemination is also a very big challenge. Yeah, the recent assessment report by the AR6 by the IPCC, they said that yes, the climate is changing. It's changing very fast. And the line what they mentioned here is the recent changes in the climate are widespread, rapid, and intensifying, and unprecedented in thousands of years. It means what? Nothing is good about it. It means what? Their spread is very big. They grow very fast. They intensify very fast. and they are unprecedented. Unprecedented means earlier this type of event probably might not have occurred maybe in the last 1,000 years or something like that. This is something, a very big alarm that IPCC has put forward in front of the society. So when we talk about the observation, because IPCC also must have taken a lot of observation of last maybe 100 years, 200 years, 300 years, etc. So what an observation will include. So if you see here, so we have observations, basically three regions. One is over the land, another is over the oceans, and third is from the sky, probably. And then of course you have the space observations also nowadays. But let us concentrate on the ground observation. So on the ground, we have, if you see the right hand side, you see one radar in there. I'm sure you must have seen, many of you must have seen the radar or its radar product also. That also I'll try to cover it up very briefly. Okay, so it tells what are the type of cloud it is, what is the intensity, how much precipitation it can give, how fast it is moving, and so on and so forth. Especially they are used for the severe weather like cyclone and extremely heavy rainfall. Then we study this is called as a radio sound. So radio sound means what? There is one hydrogen filled balloon to which the one instrument is attached, and then it goes up. And when it is going up, it will measure the temperature, humidity, pressure, everything, and it will send to the ground level. So I'll come to know at different height what is the weather, how the weather is changing, how the winds are changing. All this data goes into the model. So what we see here, radio sound, this goes about 25 to 30 kilometer up. Then you have something pilot here. This is called as pilot sound. Pilot sound means it's a small balloon. That goes, maybe 3 to 4 kilometer maximum. And that also has the same application that it tells, the wind. Rather, it tells only the wind. What are the vertical winds in that lower atmosphere? Then you have something called as drop sonde. This radio sonde and drop sonde are opposite to each other. Radio sonde goes from ground to up. Drop sonde, they are taken to the sky, and then from there they are dropped and they fall with the gravity. And when they fall with the gravity, they go on recording the different weather parameters and the data is retrieved. In addition to these observations, we have the observations over ocean. Kerala, a beautiful state, and it has a very good coastline also. So a lot of coastal observations are also playing very important role. So what we have there, we have the buoys, we have the drift mood buoys, where every time the temperature and the wind will be measured. Then we have ships; they also take a lot of observation. Then we have the sky observations, like the aircraft. Aircraft also take a lot of observation. So there is a system called AMDAR, AMDAR. So this type of data transporter system, on the belly of the aircraft, they have the sensors by which they will detect the temperature and the wind. So once they detect the temperature and the wind, they will send it to the ground level. So wherever the aircraft is moving, you will get real time the wind and the temperature data of that particular level where the aircraft is flying. And then you have the other things like geostationary satellite. Lot of pictures, satellite pictures are available on IMD website. Most of them are from the geostationary satellite, where you see all India, and around that you see the Arabian Sea, Bay of Bengal, and Indian Ocean, and then you see a lot of clouds, etc. So that is a fixed satellite. That's why it is called a geostationary satellite, because with reference to the rotation of the Earth, these satellites are stationary. Okay. Then you have polar orbiting satellite, like they move south to north and north to south. So northbound and southbound satellites are there. Of course, geostationary satellites are on a very high altitude, whereas polar orbiting satellites are at very low altitude, less than 1,000 kilometers. And then you have, the GPS satellite also, which, when you are navigating, somebody explains you that where to go, how to go. It's a GPS, which is actually, making all that difference. GPS satellites are also used in the weather observation for knowing the different heights, etc. So when I was talking about all those observations which have been taken by the different land and ocean and sky, all those observations I have listed probably on the left-hand side of my this slide, that you have the surface observations. They could be manned, manual, automatic, upper air observations, aircraft, and then ship observation, ocean, satellite observation. All this data, 24/7, every day, every 15 minutes or every 10 minutes or every 5 minutes, the data comes to the main server. Let us say is the regional telecommunication hub, which is at Delhi. Then it is generating. It goes to the different places, like it goes to the National Weather Forecasting Center, Pune, to Delhi, and then we have one office at Pune from where I am talking. It's a second headquarter for the India Meteorological Department, and then we have the data also goes to the IMD New Delhi, NWP, that is numerical weather prediction, and then NWFC, that is National Weather Forecasting Center, generates the national forecast for the entire country and for the states in coordination. When they're doing it for the states, they coordinate with the regional offices. For example, your regional office is Regional Meteorological Center, Chennai. So under that Chennai, Kerala also come, and then you have Meteorological Center, Kerala office at Trivandrum. So this is how the data flows and the forecast is generated, and then you have a lot of state and the central government and media and public stakeholders who would be using this data. In addition to that, we have the radar data, we have the global data also coming into the picture. It is not only the ship observation, etc., but the global data also comes in the scenario, because model require not only the regional data but the global data also. Let's move to the next slide. So this gives you the flavor of how the different observatories and different observational networks are spread across the country. So we have the surface observatories where the manual observations are taken, like we have one in Trivandrum in Kerala. You can also always visit if you have not done so far. Then we have some non-departmental observatory where we take help of different agencies to take the meta observation. And then we have the automatic weather station, we have automatic rain gauges, and also we have the high wind speed recorder. This high wind speed recorder plays very important role in, especially when the severe weather like cyclone is expected. Today only India Meteorological Department has given a forecast that there is a possibility of a very likely possibility of a development of the cyclonic storm somewhere around 24 or something like that. Maybe you can log into the IMD website and find out that what is the current status of that, whether it's a low pressure today. And with the low pressure, it will get intensified into next 3 days, and then it will form the cyclone also. So all those stages, everything is mentioned date-wise on the website. I request all of you to see that also. It is in the, it is not going to, as such, the forecast is said that it is not going to affect your state, but it is going to it could skirt. It will go from very near to the Orissa, and that once it comes near the coast, it will turn, and then it will start traveling towards the coast from the Orissa to West Bengal. Yeah. So coming towards the radars, they play a very important role. Many times people tell, of course, this is what the entire radar network, what you see on the left-hand side, that we have different types of radar, different frequencies of radar, because I have different applications. For example, a cyclone detection radar, will have a range of 500 kilometers. You can see something up to 500 kilometers. But then there are other radar, like it will be a C band or X band. Definitely, it will have the lesser distance at which it will be able to do the cloud surveillance. So if you see here, countrywide, entire country, I think it is almost covering the entire country. And some of them, there are some gap areas, definitely in the central part of India. But there also, we have a plan to put some radars in that area also. So the radars play a very important role. When the cyclones, they come near the coast. When I say near the coast means what? Near the coast means in the range of radar. In the range of radar, means it is less than 500 kilometers. So whenever the cyclones or the severe weather system comes in the range of radar less than 500 kilometers, then the radar and the satellite, they both start taking their observation, and then we get a lot of more information. I've shown here some of the radar installation, some of the radar buildings. We install some radar, like in the center one, is a big radar. This is put on a building, whereas this is a small radar. It is put on a steel tower. So it has a different application, it has a different range, it has a different frequency, and so on and so forth. So this is how a radar observation will look like, which is always available on our website. Let us come to some significant events. How was 2022? We are in the month of October. So if you see here, it impacted, what was the impact of the severe weather across the country? All the blue areas in the graph indicate that they were affected. They were affected by, this is district level diagram, they were affected either by the flood or heavy rain. And then you'll appreciate in this diagram that there are 2 or 3 types of severe weather where you see either it is flood or heavy rain, or it is lightning and the thunderstorm. Lightning and thunderstorm, if you see here, probably it is in the Bihar and UP side and some part of the northeastern states also, and the easternmost central India. Of course, Kerala, there are some instances where we get the lightning and thunderstorm. Thunderstorm is obvious, but lightning also sometimes we get. But the more frequent lightning and thunderstorms are there in this particular area, which are red and orange. But rest of the country, if you see, it is more or less blue color. It means there are in 2022, the flood events were more. Monsoon was very active during the 4 months. What was the performance of monsoon during the heavy rainfall event from June to September? So if you see here, I've tried to plot the graph of events and the stations from the September. This is for the very heavy rainfall. Very heavy rainfall, we have actually basically 3 categories: heavy, very heavy, and extremely heavy. Extremely heavy means more than 20 centimeter or 200 millimeter. Very heavy means we can say 12 centimeter to 20 centimeter. And anything less than 12 centimeter to 6 centimeter, 6.5 centimeter, it is called as heavy. So we have heavy and very heavy. When you plot it here, you see there are a lot of dots you can see here. But then there are many areas where you don't see the dot. What it indicates? That entire west coast, right from Kerala to the North Maharashtra or Gujarat, lot of dots you can see. So heavy rainfall events were more on the west coast, and of course some parts of most parts of Orissa, Telangana, Andhra, and some parts of MP also, and some northeast region also. And if you see the extremely heavy rainfall plot for 2022, then you will see that the dots are less, because the rainfall is more than 20 centimeter. Doesn't happen, at so many places every time. But you'll again appreciate that what is the trend here and here is more or less same, that the extremely heavy rainfall was confined to the west coast here, and again some part of the Madhya Pradesh, and then again some part of the northeastern region, and again some part of the Orissa and adjoining states. So more or less the geographic locations are same, only the numbers are changing, or it is little less extremely heavy rainfall. So what happened in 2022, June to September? How many times the floods and the heavy rain came? How many times the heat wave came? How many times thunder and lightning occurred? How many, etc., and the grand total. So if you concentrate if you see here, probably there are some big numbers out there. So other than the Kerala, which is here, I would request you to see the Bihar. How many times the thunderstorm and lightning was reported? 236 times. The lightning and thunder was reported. Then if you see MP, Madhya Pradesh, 88 times. Now let us come to the flood and other situation. If you see here, Himachal Pradesh, 64 times, there were events when the flood or the heavy rains occurred. For Kerala, the heavy rains or the floods occurred 26 times in this year, that is 2022. And of course, that same is replicated on the graphical position here. As I said in the beginning of my talk, that the observations are very important. To take the observations, we need observatories. So, if you see at a glance how the Kerala looks as far as the observations are concerned, yes, we have observatories. And what are the different observations we have? These abbreviations, if you are not sure about it, I will explain it or I'll convey it here. AWS means automatic weather station. We have more than 100 automatic weather stations in Kerala. And then agro AWS, there are 3. Then automatic rain gauges, 30. Then DRMS means it is district, there is a scheme, the district rainfall measurement scheme. It's a combination of the state and the IMD. So we have 88 places where, in Kerala, we have this rainfall measurement. How many surface observatories are there? We have got 14 radars. There are 3 radars, okay? And then buoys are there because we have the sea also. So wave buoys are there, and then cal buoys are there, and of course the data buoys are there. So they are all on the ocean side. So if you see here, Kerala looks pretty good as far as the observational network is concerned. I will come to a few more slides about it. But then there are some gap areas. Gap areas are near this Urukki, or this is the place in the South Kerala in the hilly terrain. We have not much observation. Similarly, in this Palakkad and little above, why not? Probably here also we don't have much dense observation. And of course, at the Kasaragod also, there could be some area, or maybe in the part of some districts of the Kannur, some places, observations are, maybe we require some more observation. So, this is how, the Kerala, as far as observation part is concerned. Let me assure you, this water picture you see here, probably this is one of the best picture what we have. It means we are, sufficiently good as far as the observational network in Kerala is concerned. But we need to plan, or we need to think how some of the hilly terrain of the Kerala can be covered up with some observation, because a lot of things happen in that area also. So this is about, the observations. Again, I was telling you, same thing. So rainfall observations, okay. So like, how the rainfall is measured, who would measure it. So district level, state level observatories are there. Agro AWS also measures. Automatic weather station, automatic rain gauges and surface. They all measure the rainfall, okay. And again, I have separated out, the different observation system like AWS, Agro AWS, and automatic rain gauges. Agro AWS, it has some additional features, like, it measures the soil moisture also. It measures the leaf temperature also. So soil moisture at different, level under the ground, So some 3 to 4 levels it will measure and it will give me the data in the real time. And then these are the surface observatories where the manual observations are taken. So you can visit any observatory which is nearer to you. So the monsoon climatology of the Kerala, this is a data of last 50 years. If you see, Kerala receives rainfall. I should say that it receives more or less good rainfall in pre-monsoon, southwest monsoon, and northeast monsoon. Pre-monsoon means it is from April to June, okay, April to May, March, April, May it receives, and that is about 359. And then if you see the percentage wise, which is on the right hand side here, it is 12.4%. Southwest monsoon, probably the best season where the Kerala gets almost 70% of the rainfall of its annual budget. And then the northeast monsoon we have, which is going to come very soon, and that percentage is around 17%. So Kerala receives, more or less, I should say, apart from the winter, like January and February, maybe all the rest of the 10 months, probably Kerala receives good rainfall around 12 to 70% of the entire quota. And of course, this is a month-wise distribution of the rainfall, where we all know that how during the monsoon season it is very high. Let us see what is happening to the trends in the rainfall. When I see this, try to concentrate on this graph where you have two lines here. So one is, the blue line is annual rainfall of Kerala, and the green line, is the annual monsoon rainfall. So blue is annual and green is the seasonal rainfall. This data is from 1989 to 2017 or 18. We don't see much changes. Probably if there's a change, probably it's not very highlighting. So I'm not able to make any changes or any convincing result out of it. So what we did, we thought that June, July, August, September, we will break it in every 4 months and we will try to draw the maps. And then this result has come. So if you see these two graphs on the top, the purple and the green are June and July. So again, the same period, 1989 to 2017-18 period. So we see that this is something very interesting, that in the June and July rainfall is slowly showing a decreasing trend. Okay, in Kerala during the monsoon season, June and July rainfall is showing some decreasing trend. Whereas the August and September, August is a blue line and September is the orange line. This particular rainfall of August and September is showing a sort of, increasing trend. So entire monsoon of June to September, I see that the first 2 months, probably the rainfall is in decreasing trend, showing decreasing trend. Again, this needs to be confirmed. This needs to be studied more. It cannot be just taken as a statement. But this is an observational data. Why it is happening, that also we need to study. And August and September, it is showing increasing trend. These are the graphs which are increasing, the heavy rainfall. The heavy rainfall also from 2001 to 2022, okay, for last 22 years, it is showing that the heavy rainfall, the number of heavy rainfall and above heavy, like very heavy and extremely heavy, in last 22 years, it is showing a increasing trend. Now, if that is happening, in that case, something should be checked also about it. So, it is not only during the southwest monsoon, but even the northeast monsoon, probably the trend is more or less same, but it is not showing a very clear-cut guidance that it is increasing or decreasing. But yes, 2021 monsoon was really very good for the number of heavy rainfall events. If you check during October, November, December, probably will see that a lot of peaks are available in this particular region. But what the point here is, the northeast monsoon also can severely affect the Kerala on some occasions. Try to capture two major events. One is 1924 and 2018. That is 2018, the recent rainfall. So 1924 and 2018. So 1924 is this purple line. So on 1994, there was a very big flood, and it started happening somewhere in the month of mid-July, that the rain increased very suddenly and then it continued to do so. Whereas in 2018, which is a recent floods in Kerala, if all of you remember, August, the floods came in Kerala, the rainfall, you see the suddenly spike is there. Green is a normal rainfall line. So suddenly you find that, there is an increase in the rain, but later on, the good thing that it did not go much higher. So we had some two difficult situations in 1924 and 2018. This also graph is indicating that how the different weather phenomena can yield or can impact or can generate the very high rainfall values. So here, if you see 2018, which I was just now mentioning, that this is observed rainfall in the month of August, and then it is a combination of all the high pulses of filters of 20-60 days, 20 days, and 5 to 8 days. So this is what is happening. Same thing, 2022, this year also, you will find that probably somewhere around 3rd or 4th August, there was a increase in the rainfall, and also around 19 or 20 August, there was a hike in the rainfall. Heavy rainfall events in the southwest monsoon 2018. Okay, I'm going to show it 2018, 19, 20, 21, 22, something like that. It's very typical. June, you see the dots. They're all location of heavy, very heavy, and extremely heavy. Red is, extremely heavy. July also we see something. August, probably lot of peak activity in the 2018, where there were a lot of flood situation in Kerala. This is something we all must be remembering. But September, almost there was no activity of the rainfall. So this is a very peculiar, situation that, something very, very severe in August, and in September, nothing. And this is a category in which, the rainfall are reported in different areas from 2018 to 2021. Yeah. So same graph which just now I shared here. You see that in the September, nothing was there, 2018. Why Kerala should get the rain so heavy? There could be some standard synoptic situation. Synoptic means weather situation. So what is one of the weather situation? There's a monsoon trough, a system called a monsoon trough. So when the monsoon trough goes into the foothills of the Himalaya, this can be very well forecasted. At that time, there's a lot of rain in UP and Bihar and those places. At the same time, there's a lot of rain in the southern peninsula. But in central India, there's a monsoon break sort of situation. So whenever you will hear next time that the monsoon trough is likely to go to the foothills of the Himalaya, be sure that the southern peninsula, including Kerala, is definitely going to get a lot of rain. And then there are other 3-4 parameters like, the strong southwesterly winds, okay, from where the monsoon comes. And then we have the easterly flows, and then also some systems over the Arabian Sea or over the Bay, a deep depression or cyclonic circulations or cyclonic storm as such. So there are some standard weather pattern by which, the Kerala can get affected with the heavy rainfall or extremely heavy rainfall. Let us see last 3-4 years what happened. So if you see here, last 3-4 years, June, July, August, September, I have tried to copy the extremely and very heavy rainfall event. Again, you see 2019, August, you see a lot of dots. So August and September, as I told you that August, September is showing, something more than June and July. So you see that the trend is almost there, that August and September are showing more number of heavy, very heavy and extremely heavy rainfall. Same thing is happening in 2020. 2021, also we see that August is showing more number of dots. It means, more number of extreme or very heavy rainfall event. And then 2022 also almost came like that. So if you see June, July, August, September, probably, I think, as a student or as a weather enthusiast, you can take that probably August could be a month where, we need to be more alert. We need to be more focused on the weather update. Of course, June and July and September also, otherwise. So what we observe, what has happened in Kerala in last maybe 10 years or 50 years or 100 years, what has happened? So let us say that about the heavy rainfall. So if you see June, July, August and September. So let us see that in the month of July, this one is this graph. All blue dots are going down. It means what? The frequency of the heavy rainfall days are decreasing. Okay, that is what I was trying to convey. Whereas in the month of August and September, there is an increase here. There is an increasing trend here. There is increasing trend here, and there is increasing trend here also in the month of September. So if you see August and September, as I showed in that line graph of 4 months, it is showing that the last 2 months of monsoon probably are more active than the earlier 2 months. The trend of the dry days Dry days means no rainfall. Since I showed you that the September and August, there could be more increase in the rainfall, but dry days are less in the September. So all the September month, the trend of the dry days is showing decreasing. Arrows are going down. Whereas in the month of June and July, the number of dry days, including August, they are increasing. Now, why this is happening? This is a typical climate change scenario. The climate change scenario says that overall rainfall is going to increase. Now, if the rainfall is going to increase, it's a good sign. But then there's a catch. When they say that the rainfall is going to increase, they say that the entire 4 months rainfall may come in 10 days. That is what can happen. And if it comes in 10 days, rest of the days could be dry day. So that is not good for agriculture. So you have longer dry days or longer days with no rainfall, and then suddenly a downpour causing the flood situation. It is not good for agriculture. It is not good for disaster management. It is not good for water conservation. It is not good for the health also. A very nice graph, drawn by one of my colleagues in CRS office Pune. It indicates that last 121 years, what is happening for the rainfall in Kerala. So rainfall in Kerala, if you see here, it is showing some decreasing trend. It is showing some decreasing trend. 1901 to 2021, still last year, it is showing decreasing trend, and statistically, it's a significant negative. So 99.9% it is sure that the rainfall, overall rainfall, the gross rainfall figure is slowly decreasing in last 121 years. Now this is something we need to check once again. Then the moderate rainfall. As I told you that the number of heavy rainfall days are going to increase, the moderate rainfall days or light rainfall days are going to decrease. Again, here also, if you see this graph particularly, you find that from 1900 to 2020, that's 120 years, you'll see that the graph is decreasing trend. It's showing decreasing trend. Means what? It is showing that the frequency of the moderate rain are going to decrease. So what? Light to moderate rainfall days are less, heavy rainfall days are more. That is not good. And same thing is graphically indicated here in the earlier days. Like this is, last 20 years, this is last 1901 to 70 year, and this is again 50 years. So you'll find that especially you'll find that there is a moderate rainfall. This red means it is decreasing. Most of the places in Kerala you'll find that in last 50 years, the rainfall days with the moderate quantity are decreasing. Of course, some places like Idukki and this south hill part, that is showing some increase in the trend. Similarly, when we talk about the moderate rain, we talked about the rain, we talked about the moderate rain. Now we will talk about the heavy rain. So when you see the heavy rainfall, it is showing some trend. It is showing some trend of decreasing, but it is not that decreasing. Okay, it is more or less a flat line, you can say. And when you see the graph again with the same graph of last 20 years, last 120 years, and then again this is of 70 years, and then again this is of 50 years. You'll find that suppose if you take the 1901 to 2021, almost 120 years, you'll find that the number of heavy rainfall days are events, rather not days, heavy rainfall events over Kerala. In North Kerala, they are decreasing. In the central Kerala, they are increasing. And interestingly, when you take off 120 year and when you see the last 50 year, this is something which you must concentrate. This graph number 1 and graph number 3. If you see the graph number 3, in the last 50 years, the heavy rainfall events are showing the increasing trend. And at some places where the dark blue is there, it is showing increasing trend and it is significant. Significant means the confidence level is very high. So it is showing increasing trend, but that increasing trend is recent. So this is again is going with the climate change statements also. So this is not only happening with the rainfall, but it is happening with the temperatures also. So the minimum temperature and maximum temperature in Kerala also showing some increasing trend significantly. Some of the stations like Kozhikode, Kannur, Palakkad, and all those stations, Kottayam, Trivandrum, all stations have tried to bring data here. The data is of last 40 to 50 years data we have taken, and then we see that both minimum temperature and maximum temperature is also showing some increasing trend. Of course, the heat wave is still not very much in picture in Kerala, but because of the coastal marine influence. But I'm sure that it is showing some change in the temperature changes also. And then when you see what is the risk involved? So we see, as far as the flood is concerned, the number of floods here on the first picture, the number of floods are showing increasing trend at many places in the Kerala. The number of flood events are more here and in this place, in the south and in the northern part of the Kerala. Similarly, the index, the vulnerability index, which has been calculated by the IMD at Pune, it is showing that there are some districts in Kerala which are red in color. The vulnerability index is very high. And similarly, when we cover up all the categories of the heavy, very heavy, and etc., and when you draw the Kerala again, you see that almost there are some 1, 2, 3, 4, some 6 to 7 districts are showing high to very high vulnerability index. It means what? Kerala is prone for certain vulnerability because of the heavy to very heavy rainfall. Similarly, when we talk about the heavy rainfall, we also talk about the thunderstorms also. So thunderstorms are also, I'm sorry, average number of thunderstorm days. If you see in Kerala on the first graph, again it is showing, a higher range from 35 to 40. Similarly, the vulnerability index in Kerala, if you see that correspondingly, not all the places, but some districts are definitely showing high value. And when you combine heavy, very heavy, I think this graph came on this earlier. Yeah. Similarly, the wind also we find that is the total number of disaster heat waves. Okay, total number of disaster heat waves. Okay, in Kerala, that is from 1969 to 2020, it is showing some higher value. Okay. Similarly, the total number of days. Okay, the lightning again it is showing some higher values here. You will wonder that what I am trying to show here. All this I am able to interpret, or all this I am able to share it because there is an observation available. There is a record available, well documented record is available. That's why these observations are very important. When I am telling you that last 120 years what happened in Kerala, it means for last 120 years I have daily weather observation, and it may be 8 times or maybe more than that also, that observations are available for Kerala state. So these observations, they play very important role. There's another, another severe weather which affects Kerala is, the cyclone. I will not talk much about it, but yes, now to, have the cyclone, how the cyclone is observed. Cyclone is observed, by the radar when it comes into the radius of 500 kilometers. Before that, it is observed, with the satellite, and also it is observed with the buoys which are there in the ocean. And also when it comes near the coast, we have high wind speed recorder, and of course we have a lot of model guidance. And this is the way a lot of geostationary satellites and polar orbiting satellite, all these observations are collected, and ocean observations are there, temperature observations are there, wind observations are there, and all this data, is very important, especially when the cyclones are over the ocean. When it comes near the coast, then we have a lot of observations over the coast, nearby coast also. In the recent year, Kerala being on the west coast, this is the data from 1891 to 2021. So tropical cyclones are increasing. Okay, so slight increase is there. I'll come to the next graph. It will show something more. So when I'm talking of Bay of Bengal and Arabian Sea, okay, so Bay of Bengal, okay, this is the first graph where the number of cyclones are showing some decreasing trend. Not very sure, but this can be verified. And in Arabian Sea, we find that recently, maybe last 15 to 20 years, we see that there is some activity again on this side in Arabian Sea, and a lot of there are a lot of disturbances developed, especially in the southeast Arabian Sea near the Kerala, and then they move toward the Yemen and all that. So we have another data here that what is happening because of the lightning and thunderstorm also. So if you see the second graph here, the death due to lightning and the thunderstorm is showing increasing trend. Okay, this is showing the increasing trend. Of course, this is not pertaining to what I mean to say is not pertaining to only Kerala. It's a national data. What I'm trying to share it with you. And then extreme heat events. If you see how the different districts are covered with extreme heat event, okay, heat wave. Probably Kerala is not much affected, as I told you. It is showing some increasing trend of heat wave. As you see here in this graph, the arrows are going up. Okay, so it is showing that there is some increase in the heat wave trend, but definitely it's not as high as what you see. Some solid arrows like northwest of MP, northwest of the India, that is Rajasthan, Gujarat, some part of central India, that is Maharashtra, and of course Orissa also. So Kerala, yeah, okay, increasing, but not significant increases there. Cold wave, I think Kerala, probably so far, to the best of the knowledge of IMD, probably we are not seeing any cold wave condition in Kerala. And then the combination of the heat wave and the cold wave, if you see, this at all India level, and then we see that the heat waves are increasing, and to basically to mitigate or to handle those, we have something called a heat action plan, and it is the plan of IMD with the state government, IMD with the municipal corporation and different agencies in that particular state, in that particular city, etc. Like that, we have it in Ahmedabad, like that we have it in Surat, like in Maharashtra we have it in Nagpur, and in Orissa, Chhattisgarh. There are many states where we have this type of heat action plan also. Yeah, Kerala gets affected with cyclone, as I told you earlier. The index of Kerala, the return period, if you see here, the return period is yellow in color. Yellow means what? The cyclones are not that frequent, crossing the Kerala coast. They may get developed. The genesis may start low pressure system near the Kerala coast, but most of the developed system over the Kerala coast, they move northwest toward the Oman, all those places, right? If you see, very rarely, I'm not sure, other than the Oki cyclone, probably, I think the number of cyclones coming very close to the Kerala is very, very less. But definitely it gets affected by the weather or the cyclones in the east coast also. So we have end-to-end early now to handle all these things. So as I was telling that, the first graph, the first block here, you say monitoring of the weather and the to initiate the alert. So once we monitor the weather, we know, and then we initiate the alert. It goes to the Disaster Management Authority, Ministry of Home Affairs, and many other people, and then the warning is issued. All warnings are in yellow, orange, red, depending upon the severity of that. And then it goes to the different agencies on different platforms, and it goes to the different languages. If you are in Kerala, it will go into the English, it will go into the Malayalam. If you are in Chennai, it will go in Tamil, and it can go in. If you are in Karnataka, it will go in Kannada also. And then these are colored warning, there are audio messages, there are video messages, and there are text messages also. And many times the text messages would be in the local language so that people understand it. coming towards what is the forecasting skill. So forecasting skill has improved in IMD in last 15, 20 years. Yes, sir.
Hosalikar, how many slides you have got more?
Maybe another maximum 10 minutes. Maximum.
Yeah. So we can some question and answer also. There are many people are attending, so it may be interesting.
Definitely. I will cover. So broadly, if you see, I'll just keep this slide, but I will talk something more. So the thunderstorm, the thunderstorm warning, what we give, the accuracies, the recent, accuracies what we have is more than 80% accuracy is there. And when we talk about, the 5-day forecast, the accuracies are around 60 plus. And when we are talking about our heavy rainfall or, the severe weather warning, the accuracy is around 70%. The broad idea I'm telling. So when we give, that is going to rain very heavily in next 3 to 4 hours, or maybe there could be a thunderstorm, the accuracy of that forecast is more than 80%. And a 5-day forecast, the accuracy is around 70%. But of course, this forecast is updated every day. So whether we are on the right track, there is one more thing. In meteorology, ignorance knows no boundary. What do you mean by that? If you don't have observation at any other given place, forget Kerala, at any other given place, it can affect the weather forecast of Kerala. So I cannot say that, okay, I don't have, good observations in Tamil Nadu, I don't have observation in Kerala, or I don't have observation. It can affect the other places too, because finally this data will go to the numerical weather predictions also. So based on that, the WMO, the World Meteorological Organization, have recently, come out with a 2 big concept called as, Global Basic Observing Network, and second is the Regional Basic Observing Network. I will not go to the detail of this slide, but what the world is expecting. World is expecting that we must have 24/7 observation. Minimum observation should be available, and they should be shared also. So once it is shared, the basic observations are shared consistently. Probably, the global forecast of numerical weather prediction, the guidance will improve, and numerical weather predictions will get good input. There are many areas where we don't have observations in the world. That is what that's why this GBON is made. If you see the worldwide picture, this again I've taken from the WMO slide. This indicates different colors. It indicates that how frequently we are sending the data. So orange means partially reporting, green means fully reporting, and red or black may very few or silent, etc. So not that India is not reporting. Probably there could be some issue related to the time of sending the data. So that also could be one of the reasons. But otherwise, we are taking all the observations. Similarly, as I told you that the global, then we also need the regional basic observing system, because that will actually complement the global observing system also. Importance of probably this could be my last 1 or 2 slides. So importance of the weather observations. So what are the importance? When we say that whatever observations we have currently, are they enough? Whether it is in Kerala or all over India? Probably the answer is no. Because this is something, we want every day, that we want more and more observation. So some of the bullet points which are here, that the weather forecasting provide range of significant societal benefits. Of course, we all know that, okay? And the forecast quality, the quality of the forecast of the numerical prediction will depend upon the global real-time observation. If you want a good forecast, we need good observation, we need widespread observation. And then similarly, they play a vital role in climate monitoring, because if I want to tell you what happened 100 years back, I must have the data with me. And then impact also. And then there is something called as, that we generate more data at the national level, but probably we are not sharing internationally. This is something, a big problem. Okay. And then the last 2 lines are very important, that improvement in the coverage and the exchange of the surface-based observation can deliver additional benefit, at least 5 billion per year. These are the global figure. This statement I have taken from a published paper from the WMO. So So it means, it has a lot of economical impact also. And that's why the last line very important, that yes, I think investing in improving the surface-based observation in developing countries is highly economically efficient. So we must invest in observation. Summary, yes, we have a lot of observations. At the same time, we note that 8 out of 10 warmest years are recorded in last 10 years. Okay, so the better understanding of the extreme, there could be a lot of, you require a lot of observation, you require a lot of high quality observation, you require consistent observation. And definitely, there has been, I would like to stress this point, that there is a significant contribution toward this from all the states, including Kerala. We get a lot of observation. I told you DRMS data is there. So Kerala shares a lot of rainfall data and a lot of other data with us. So like this, when we work in an integrated manner, probably I think, so what we can do is, one is, summary, that establishment and maintenance is a continuous process. Today, Kerala has more than 100 AWS. We may like to have it more also. Okay, there could be gap areas. I told you that there are gap areas and they need to be addressed, especially CC means climate change. And then we need to find out what is the impact. And based on the impact, we can design the network also. Where some places you may require more dense. Observations need to be accurate, consistent. And then one more last point here, that it needs an integration of different network from the state, from the central, from the different agencies, from the corporation. So that what happens, we use the resources maximum and we come out with some better result. So that's why the importance of the observation needs to be sensitized. Thank you. Thank you very much. I'm stopping here, Faisal, so that if there are any questions, we can.
Yeah. Thank you, Dr. Hosalikar ji. Actually, very exhaustive and very informative lecture. So you started from importance of observations and the observation network in the country. And as we understand, in the beginning, globally, the main aim used to be generally the observation network is to, track and monitor and in fact predict the systems which produces the weather actually. So the network was planned in such a way that not a single weather system that gives you, weather not to be missed and forecasted. But with the global warming becoming more important, local events has become more. Now that network importance is to not to miss even a single extreme weather rather than the system earlier. So now, as a result, globally there is, as you correctly said, there is efforts to improve the network, observation network, and already IMD is contributing significantly in improving for last several years, and even for Kerala also. But the important point is that using this data, how instantly this information can be reached to the public, and how that can be benefited. That is one point. Anyway, before I ask question, that we have got many, almost 50 persons are attending from very beginning. It actually shows the interest in this particular topic. So before I ask some question, I welcome those who are attending this lecture to ask any question. And then once that is done, I have got one or two questions. So it is from the audience first. Anybody from the audience? You have any question?
So there is one question. What is the reason?
Yeah, Chiranjan Prabhu actually. So he has question. Chiranjit Prabhu, sir, what is the reason behind the increase of heat waves trend in the Western India and decrease in the trend in the Eastern India, right half of India?
Yeah. Basically, if you, it is a good question. Actually, The heat waves they generally occur in the month of the March, April, May, or sometimes in the month of June also. And the preferred area for this type of heat wave is the northwestern part, northwest India, part of Rajasthan, Gujarat, and the part of MP, and of course the interior of Maharashtra. Part of central India, Orissa is also very much prone for this type of heat wave. The coastal places, they don't get much sort of heat wave because that's a marine influence. You have the sea breeze and the land breeze every day rather. Otherwise, in case if the other system is operating, so we have this type of thermostat available on the coastal places where the temperatures are not allowed to go very high. But in this particular area, which are the northwesterly area, you get a lot of warm winds, basically from the areas like Pakistan and also from the northern part of the country and from Afghanistan. So that is one of the places. And then we have one heat low is also during the monsoon period, pre-monsoon time. We have this type of heat low which is getting developed. So these are the basically heat-prone areas where this type of temperature can go. I mean, this can go very high. And of course, the topography also plays very important role, like the deserts of Rajasthan and around the area. That also could be one of the reasons.
Yeah. Okay. I think Chiranjit Prabhu is happy with your explanation. So anybody else? Nita, you have got any?
Sir, I don't have any questions, doubts as such, but only one question, like, do you have any plans to set up any flood warning system in Kerala?
Yeah, we would definitely would like to, we started with, Ministry of Earth Science, that it started with Chennai, and then we started in Mumbai. We did it in Mumbai. There is some work going on, very preliminary work going on in Calcutta. If this type of flood warning is required by the state government of Kerala, because this requires, basically it is not only the Met Department or MOA. There is a lot of hand-holding is required from the state government and the local. And we cannot do it for the entire Kerala state, but Dr. Pai also knows. But maybe we can identify certain areas, cities which are more prone. This can be studied. We will require the digital elevation, graphs, and many other things where this is possible, provided this requires, because this requires a lot of investment also, observational network also. We can do it not for the entire state, but maybe some places in Kerala where they are much flood prone, which can affect the routine life, and of course the other things.
Yeah, in fact, Nita comes from Cochin, and they are a very low-lying area, many low-lying area in Cochin, and recent years, a lot of flood events has been observed in Cochin, Ernakulam district. So
Yes.
at the same time, as I understand, there is not a good network of ARG or AWS, in many, particularly in the western part of Cochin. So
Right.
I think CWR, can take initiative in putting at least some ARGs in western Cochin, areas. So though there are 4 or 5 now within the 100 AWS within that IMD has put in the eastern part of Cochin, but CWR can do, I think, some initiative to get some.
Yeah, that's why Dr. Pai, I told you that it requires a lot of money.
Yeah.
That's why multiple agencies would be better option.
Yeah.
Sir, I am Dr. Sandosh from Groundwater Department, State Groundwater Department.
Yeah, you can, you can introduce yourself. He is from groundwater. Yeah,
I am Dr. Sandosh from Groundwater Department.
Yes,
So
sir.
we know that Kerala has passed many disasters like heavy rainfall, and we are passing through many climatic changes recently, and many more to come. My doubt is that even after getting such flash rain and cloud bursting, our groundwater resources are estimated as declining. The estimated groundwater resources as per CWB report, the GEC report, shows that our groundwater resources are declining. So what are your suggestions, valuable suggestions to state government of Kerala to manage this thing?
I'm not expert in that, but I will tell you something which I know little about it. One is, one graph was shared, where the Kerala rainfall, June, July, August, September, is showing, a bit of decreasing trend. Number one. Number two, June, July are not, June, July are showing again decreasing trend. August, September are showing increasing trend. The third, because it's a coastal place, I'm slightly surprised that how the groundwater level is going down. That's not happening, in Maharashtra, in the Konkan region. But still, this needs to be investigated. Maybe, there is a lot of, directly maybe the water may be going, to the sea instead of, maybe, we need to develop, the land. We need to keep certain land open, marshy land, the soil land, so that water can percolate. See, we need to allow water to percolate, in the ground. If we put lot of, RCC or concrete work, etc., and then, then you have, the water flowing on the surface is very high. This can cause, a lot of flash floods also. So this also could be one of the reasons. I'm not very sure about it, but this study can be taken up. This is a good point. I think we can take up this with IMD, and joint study also can be planned with the state authority. Dr. Pai also can, can be, one of the member in that. Probably can be the lead member, rather, I should say.
So you're muted. Dr. Sandosh, you might have heard, recently in Bangladesh, they were saying that, they could control flood to some extent by utilizing groundwater during summer to make more crops, actually, spending much groundwater to that. And they found that during monsoon season, monsoon rainfall is being used to recharge the groundwater. As a result, they could control the, this groundwater, actually, floods, actually. So I do not know how, as Dr. Hosalikar said, we are getting a lot of rain in spite of a slight decreasing trend. There should be some recharging happening. Maybe that we are taking more groundwater than it could capability of recharging. So that may be the thing. And so we have to try to recharge, way of how to recharge that. Because of the slopy nature of Kerala, very small strip, entire rainfall quickly, whenever it falls, it quickly flows to ocean.
Yeah.
So there should be some way how that can be controlled and that can be used to recharge the groundwater. That's why we feel maybe some kind of engineering, we have to discuss on that.
You rightly pointed out. I remember I was in Northeast. There's a place in Cherrapunji. Probably we know that it is one of the wettest place. But during the summer period or just before the monsoon, there is no drinking water available in that. Why? Because whatever rain comes, it goes to the Bangladesh because of, the hilly terrain. So maybe in Kerala also, because of the hilly terrain and very small vertical strip, maybe a lot of water would be flowing into the ocean. That could be one possibility.
So you're absolutely right. But Kerala government, through groundwater department, we are adopting many recharge structures. We are constructing many recharge structures. Yeah. But my question is that soon after the flood, it is reported that the water level is declining. So is there any measures?
Very frankly, I think we need to, consult, somebody who is, geologist or somebody who is expert in that area. Weather-wise, whatever input is required, we can definitely provide the input if we go into the scientific part of it.
Okay, thank you, sir. Thank you very much.
Yeah, whether this water, which is collecting in ground, whether it is leaking to ocean. I'm just telling, instead of remaining there, so whether there is a porous surface, we don't know. Anyway, any other question? Anybody else? So there are many young people are there. Yeah. I heard somebody. Anybody else?
Sir, there is a question in the chat box.
Okay, you can read that. Yeah.
So there is a question in the chat box from SSC Southern Railway. He's asking, is there any plan to update isopropyl maps? It needs to be updated at least every 10 years for 20, 50 and 100 years return period. So they're asking, is there any plan to update the isopropyl map?
I'm not very sure. Let me ask my colleague. Dr. Srijit, are you there?
Yes, sir. Actually, we are planning to update our rainfall atlas. Along with that, we are planning some this type of products also.
It is going to come
With the
next
rainfall
month.
atlas, I think within 6 months we can complete that work.
Yeah. In fact, I will suggest that the Southern Railway officials, those who are attending this, they should send their requirement also to Office of CRS. If you have got a specific information is necessary, I don't think that it should take much time. Even they can only specially for you, they can prepare and give. So because data is readily available, it should not make a big issue actually. So if there is a real requirement, you can put that actually.
Yeah. I mean, you can just try that. You please send the query. We'll try to address it.
Yeah, I think it should be possible. Yeah. Anybody else? Okay, I think people have no question. I just want to know, Hosalikar sir, now that we have got a very good observatory network in Kerala. So, particularly when heavy rainfall events are occurring, many times people want to have information readily available, at any given time, last 1 hour, 2 hours, etc. So how that can you suggest that this can be, make readily available in a, say, like any mobile app or anything? You have any plan? I know earlier CRS office was going to do that.
This is a we are working with Trivandrum office, Met Center Trivandrum, and there's one group which is working on that. And there are some issues on which the matter is stuck up, but we will try to resolve that. Number one. Number two, immediately, if we want to know what is the status of the rainfall in the in Kerala, you know it that we have that automatic weather station website is there, dashboard is there where every 15 minutes data is available. But of course, it is a website. You have rightly pointed out that because mobile is there now everywhere, if it can come on some sort of application, definitely it will help the community. We will definitely look into it.
Okay, good. Anyway, very nice, Hosalikar Saab. Actually, if people have got still any other questions, they can still write to him. He can provide his email address, and
I'm writing it in chat box.
Yeah. So you can give that email. So even if not now, you can always write to him directly and get no information. As he correctly said, this all the AWS ARG data are readily available in the AWS website of IMD Pune. So people can get that information also. And for any data for research work like groundwater or any other work, those data also can be obtained from data portal of Office of CRS IMD Pune. So you can go to IMD Pune website and get all this information. Okay, so it was a very nice lecture.
One question, Dr. Pai, from one Chandani Chandran. Okay, about Agro AWS and the products available. Basically, Agro AWS is nothing but regular automatic weather station with additional sensors related to the agriculture. So regular AWS will have the temperature sensor, wind speed, wind direction, pressure, and the rainfall. So these 5-6 parameters are always there, and they come via mobile network, GPRS network to the main server. In addition to that, for the agromet, we have put the soil moisture sensor at 30, 60, 30, 50, 70, and 90 centimeter depth. Soil moisture sensors are there, and based on this soil moisture sensor, this data can go into the numerical weather prediction, and this data is very helpful, to improve the NWP forecast, to provide the guidance, what is the best time for the sowing, etc. And currently, we have put 200 agro AWS in the country. Another 330 agro AWS is already, the announcement is made, and we have already floated the tender. So that is also going to come maybe in next 1 year time. So there is again some portion which is coming to Kerala also. And this data needs to be, first of all, the big challenge, this data needs to be validated. So that we are doing currently, the existing agro AWS, the soil moisture data, that we are, getting it validated through our regular manual gravimetry method, by which, once we know that this data is accurate, this data will start flowing into our NWP models also. In addition to that, soil moisture, we have the leaf temperature also. So these are some of the sensors that we have, but very important sensor is the soil moisture sensor that has come. That is very important. We need to know what is the soil moisture.
Okay. Yeah. Chandni, are you okay? Okay. You have any more question? Or
yes,
is it okay
fine.
with you?
No, sir. No, sir. Thank you so much, sir. Thank you, sir.
Yeah. Okay. Thank you. Okay. So it is already 5 o'clock. So we have a very long session of almost 1.5 hours. It's a very interesting session. So thank you personally, Krishna Hosalikar ji. So I will just an official, for Thanksgiving, I will invite Shama.
Yeah. Okay. Fine. Yeah, thank you. Thank you very much to all the listeners for listening me patiently. And thank you, Dr. Pai. So whenever you are next time in Pune, let us meet.
Yes.
Maybe we can have some good time also. So thanks once again to you personally and to ICCS also.
Thank you. Thank you. Thank you. Thanks to everybody for joining, a large number from IMD and many other organizations from Kerala, many our sector organization has joined. Thank you all.
Yeah. Have a nice time.
Thank you, sir.